whenever we measure a height, in other words, we want to measure the height from the peg, we've got a special height hook that does it. But if you ever want to know where to measure the height to on any GPS antenna of ours, it's from the height of the peg to that surface there. That's what we call the MRP, the measurement reference plane. Because from that point it knows exactly where the center of the antenna is. We know the exact center. So whenever you measure the height, if you just got a normal tape and you wanted to measure the height, it's always from the top of the peg to that surface there. That's what we call the MRP, the measurement reference plane. But we've got a special height hook that makes it even a lot easier.
So with a tape, we should take it here.
Yeah, no, but we got it, like you'll see, we've got a special tape. When you set up on a tripod, it's got a hole in the carrier here.
Yeah.
And you'll see we've got a tape, and we measure to the white line on the tape. And then, because we know that from the white line to the MRP is exactly 0.36 of a meter. So all we do is we tell it we set up on a tripod, we measure the height to the white line, and it automatically adds on 360 millimeters to get exactly the right height.
But one thing you have to tell them, regarding elevation in Mauritius, we have to have a geoid model, but unfortunately we don't have any geoid model, so for elevation it will be erratic.
Yeah, as I say, if you want to get reasonable heights with the GPS, you must keep and say for example we know the orthometric height or the height above sea level of this point. In order to get a good height with the rover, we need to keep the distance between the base and the rover as little as possible. So say for example we had a road of 10 kilometers and we had a orthometric height at the start of the job, but we didn't have at the end of the job. We couldn't, if we just set up the base at the start of the job and punched in the orthometric height and we went 10 kilometers to the rover, the height from the base wouldn't be that accurate. If you really wanted to make sure that the height was more accurate, you'd have to measure from the base about a maximum a kilometer away, and then basically traverse with the GPS 10 stations to get the height. But because the GPS measures the height above the ellipsoid, now the ellipsoid is a theoretical line as such, whereas of course mean sea level or the geoid is a defined line. But of course the separation varies, and you don't know over the 10 kilometers whether it's undulating or just a sort of straight plane or parallel. So the only way to make sure is to keep your baselines as quickly as possible. We have got other techniques where we can check what the geoid is doing over an area, and then that will actually tell us how to handle the height component. Sometimes if the geoid and the ellipsoid are parallel, then of course you can do 10 kilometers and your heights will be good.
Just for information, I was taking that from the Ministry of Housing and Land. There's a report on the geoid model, and the report says that for Mauritius it will be difficult to develop a
geoidal model for it
because of the topographical.
Yeah, but as I say, how much height control have you got in the whole of Mauritius? I mean,
say 100.
You see, you could develop a fairly good geoidal model by measuring all your known points with the GPS and then creating a height model.
Most of our height is on the mountain, on the hills. So
you got nothing in?
Yeah, no. So that's the big problem.
Okay.
So for a geoid model, it is inappropriate to use.
Okay, so it'll be virtually impossible to tie all your heights in for the whole of Mauritius then?
It is in the report, I mean.
Okay.
So actually the government is not going with the geoid model.
Oh, okay. All right.
About here, the white line is called
0.36 of a meter. Okay, so you'll see at the base and the rover we've got two radios. As I say, the one transmits and the other one receives, but it doesn't matter which one goes where. They both transmit and receive. So the radio doesn't matter. This one if goes with the base today and the rover tomorrow, it doesn't matter. Doesn't matter. Okay, so all we do is we clip the radio on the tripod. It just clips on like that. Of course,
En bracket ça, niet meer aan.
Een bracket like that, steady. Maar een details.
and aerial clips on. Then we have basically a wire cable that goes, one goes to the radio, one goes to the antenna, and the other one goes to an external battery. That's what the only reason we need the external battery is to power the radio as such, otherwise we could use an internal battery. And it's quite easy. You'll see you've got a female plug, you've got a 8-pin male plug, and a 5-pin male plug. We know the 5-pin male plug goes to the battery. We know the female goes to the radio. I mean the female, and of course it's red dot to red dot.
Okay.
And again, you can't pull. Oh, okay, this one you can. Okay, you should never pull the cable out from there. Okay, the female one you can. The female one you can, but you should always pull it out by the knurled part, this knurled ring. That's where it should come off. Okay, as I say, on the female one, you can actually, it comes out pretty quickly, but on the male ones, it's got a locking pin. So we've got the 8-pin one, which goes into the sensor. Again,